Okay, so we've got calculating part 2 of volume. So what I've done is I've just got another couple of shapes here that we can work on, and excuse me, it would look to be quite complicated, but hopefully I'll be able to show you that it's nice and simple. Now, on the previous video, this cuboid, okay, it would just be this face area multiplied by the depth. But this cube or cuboid has a square cut out of the middle, so obviously there's going to be less volume. So what we need to do is just two calculations. So firstly, the volume of the whole cuboid, okay, so we ignore this for the moment, would be 10 times 8. That would give us the face value, and then we would multiply by the depth, which would be 6. So we can just write it like this. So we would have 10 times 8 times 6, okay, and that will give us our volume. Now you can use a calculator for this by all means. Now 10 times 8 is 80, and then 6 80s are 480, and that will be centimeters cubed, remember, because this is volume. But this cube shape has been taken out, so what we need to do is take this away. So we pretend, if you like, that this is a separate volume. So the area of this piece that's been cut away is length times width, so this would be 2 times 2, and of course if it's all the way through the block it will be 6 centimeters deep. So the volume, so if I put V2, this is the second volume, would be 2 times 2, because that would give me this face area, multiplied by 6. Okay, so maybe I should call that V1. So 2 2s are 4, and 6 4s are 24. And again, don't forget that this is centimeters cubed. Now this volume has been cut out of this volume, okay, so the actual volume would be 480 minus the volume that's been cut out, which is 24. So this will give me 456 centimeters cubed. As I say, by all means use a calculator for this. Okay, in any tests or anything like that, by all means use a calculator. And that's as difficult as that is. We find the volume of the whole thing, find the volume of what's been taken away, and then just take one away from the other. Very similar to when we worked on area. Okay. Now here we have, say we've got a little sand pit, and it's 2 meters in radius, and it's 30 centimeters deep. Okay, so to find the volume of this, now the area, remember, is pi r squared. Now if we say that pi is 3.1 for our purposes now, then this would be 3.1 multiplied, now the radius we've been given is 2, and we square this. Okay, so we multiply it by itself. So this will give us 3.1 multiplied by 2 squared. Now 2 squared is 2 times 2, so this would be 4. Okay, so if we pull up our calculator, we have 3.1 multiplied by 4, and that gives us 12.4. Now this is centimeters squared because we've just worked out the area here. Okay, we haven't worked out the volume yet. So our volume is going to be our area, which is 12.4, multiplied by our depth. Now our depth is 30 centimeters. Now we can't multiply this by 30. Sorry, this should be meters squared. Do apologise. So that's meters squared. So this is centimeters. So we can't multiply centimeters by meters. So we need to convert this back to meters. So if you remember, 30 centimeters we need to convert to meters. So we're dividing by 100 because it's 100 centimeters in a meter. So the decimal point will move twice. Okay, so this will give us 0.3 meters. Okay, if you're unsure on this, go to the conversion video. So we have 12.4 multiplied by 0.3. Okay, so we have face area multiplied by depth. So now if I go to the calculator, we get 12.4 multiplied by 0.3, and this gives us 3.72, and because it's now all in meters, it's meters cubed. Okay, so that would be our answer. So hopefully you can see that if you can work out area, when you multiply it by its depth, you automatically get volume. And it doesn't really matter how complex the shape looks, it can just be broken down. So I hope that helps, and we'll give you some worksheets and just practice.